Class, please take your seats. Now, your instructor, Vincent Finelli.
Well, let me just ask, were there any other articles that you wanted to get to before we move on to Fukushima?
No, I'm ready for Fukushima. Fukushima to me is critical to discuss, and during the discussion, we're going to need to share some of our thoughts on how to protect ourselves from this overwhelming threat.
Well, I went ahead and did the radiation this week. Again, we have to just rely that the people know how to report the meters and they're working properly. But the winner this week is Miami, Florida, with 1,485 counts per minute, which is nearly 300 times normal. And then Little Rock comes in second.
Wow, that's bad news because I was planning on traveling toward Little Rock in the next few days. Uh-oh.
Now there's no place that's really safe anymore. And
well, yeah, Little Rock, Colorado Springs, it's up there at 1387. Lincoln, Nebraska, Omaha, Nebraska, Portland, Maine, Spokane, Washington, Amarillo, Texas, Bismarck, North Dakota. North Dakota, you used to think that North Dakota would be a safe place to go. Not a lot of people who wants to go there. It's freezing cold. Raleigh, North Carolina, Bakersfield, California, Navajo Lake, New Mexico, Billings, Montana. These are all well over 1,100 counts per minute. Pierre, South Dakota, Tucson, Arizona, Idaho Falls, Idaho, El Paso, Texas, LA, Los Angeles, California, San Diego, California, Anaheim, California, all over 1,100 counts per minute. Captain John Reagan's with us, and we're discussing radiation counts per minute, and just so you know where you stand, let's continue. We are talking about San Diego, California. They count 1122 counts per minute. And going down, we've got Anaheim, California at 1119, Kearney, Nebraska at 1093, Worcester, Mass. 1078, Kansas City, Kansas 1060. That's near our neighborhood. Louisville, Kentucky 1052, Wichita, Kansas 1049, San Bernardino County 1046, St. George, Utah 1044, Oklahoma City, Oklahoma 1041, Yuma, Arizona 1039, Laredo, Texas 1036, Memphis, Tennessee, Salt Lake City, Utah, all above 1029. And then if you get down to, where things are really important, like Washington, D.C., 375. 375. The high for Washington is 375, and the low for Washington is 79. So it seems like radiation knows that the important things are going on in Washington, and it needs to stay away from Washington, D.C. Can you imagine that? How does it know, John?
Well, we might want to speculate that they've got some technology, but we don't see too many high readings coming to us from the Northeast.
Mm-hmm.
We've got one in Massachusetts that's 1,078. And a lot of this depends on exactly what the weather patterns are. But it does seem strange that they're always, they're always included on the list, but that they tend to be well below the 1,000 counts per minute that these other cities are receiving. And just point out at the bottom of the list there, it says normal radiation is 5 to 20 counts per minute. So that's what the background radiation would be. Yeah. And obviously, even on the low end, DC is several times that. So they haven't escaped, but they, for some reason, are not high on the list. Let me. Some of these links we actually talked about last week. I promised to post them. We don't have any more information coming out about the reactor at Leningrad. These are the two links that I have. It's a Chernobyl-style plant, and you can see pictures of steam coming out. In the first article, they've got a picture of a detector that is not very high on the count. Of course, we don't know if that's real or propaganda. And the second one has a map showing where they believe the radiation cloud went, which went over to Sweden. So it's kind of frustrating, much like Fukushima. We are not getting official information released from the state, and we're having to rely on other observations. I've also got
John. What an outrage! What an outrage that radiation can leak from a reactor and poison another country that has nothing to do with that reactor nor the benefit of the electricity being generated. Isn't that amazing that we have done this to ourselves? And we've done the same thing in the United States. We have reactors in one state that sends radiation downwind to other states. So, John, I know a guy who's friends with a person who works at the controls of a nuclear power generation system. And I asked him, my friend wanted to get a job there. And I said, so what's it like? And this was maybe 15 years ago. He was telling me, you just go there and you go to sleep. You get paid for going to sleep. You just sit there and you can sleep at the controls. Let's continue into the Fukushima, please.
And that's the true no child has a chance. It's Fukushima. If you're just tuning in for the first time today, it was a couple of weeks ago that I talked about a link where I found they'd recently released a government report that was from March 18th, 2011. This is 1 week after the event at Fukushima, the first event anyway. And at that time, they knew that 100% of the rods in spent fuel pool 4, 50% of pool 3, and 25% of pool 2 had already been released to the atmosphere. And pool 4 by itself released more cesium than all the above ground nuclear explosions combined. So that is what we now know and what we're dealing with, and why I'm in the middle of bringing you up to speed on radiation and going back and taking a look at what we were told at the time and the lies, and as well as other stories that we had suspicions, but now that we know this, it adds more reliability to the stories. So it's going to be an interesting journey. I still have dozens more to get through. Last week, I or I guess it was yesterday. I lose track. Last week it was, because this was already posted for yesterday. Talked about microwaves and ionizing radiation. So I included the two links. We talked about that last week, so I don't really want to spend time on that again. If you missed last week, you can find the archives on gcnlive.com. Also talked about Dana Durnford. We're hoping he's okay. He was not on Jeff Friends' show last night, and Jeff was unable to reach him. But his website has a number of pictures, and he's got tons of resources where he went all along the west coast of America and documented what things look like after Fukushima. He's also got some pictures of before for comparison. And his website's the nuclearproctologist.org. The link is there. And you can definitely lose a lot of time looking at all of those pictures and what he's produced, and especially now, knowing what we know now, it's going to be pretty hard for people to deny that radiation is at least a factor, if not the cause of what you're seeing there. I've got a couple of new news pieces. One, the link is called California Plutonium. And this is where a government report, plutonium detected in recent California air samples, fallout from Fukushima nuclear accident may be to blame. The samples were apparently taken in 2014, so it would not be the recent Russian situation, and I believe that would not have involved the storage facility there in the Southwest. So I would say again, Fukushima is probably the likelihood there. There was a discussion last night about tritium, and I'm going to add several more articles on that for next time. Tritium is basically a hydrogen atom that has two neutrons in the nucleus. And when that breaks down, you end up getting beta radiation. And one of the reasons I posted this link this time is it kind of dovetails with the measuring radiation. They have a nice chart there talking about becquerels, curies, and getting down further in the list, sieverts, rems, and it's still a mess trying to sort out all the measurements. Some of these are just the measures of radioactivity, and others consider what the effective dosage would be. And I'm going to continue working on this part as well to see if I can put together something that might be a little bit easier to understand, but at least I've put up the several sources that explain it from different angles. What really disturbs me about tritium, it's probably going to be the most common radionuclide released from Fukushima. Hydrogen being a part of water, you end up commonly getting this in water. And in fact, low amounts of tritium are just plain naturally produced by the way things work in physics and nature. But when you have these excessive amounts, you get it two ways, or I guess actually technically three ways. One is the exposure to the radiation. Beta radiation, again, is not very critical so long as you don't ingest or inhale it. Well, this is going into the water supply. So when you drink that, it's going into your body. And I guess the good news about what you drink, it's only there for about 10 days. But when you eat something that has it, it can be in your body for 10 years.
Captain John Reagan's with us. We're talking about Fukushima. And class, this hour is Fukushima 104. Previous broadcasts are 101, 102, 103. This is 104. Class, Captain John Reagan's with us, and John, we're talking about tritium. And I went to the internet during the break, and I was looking up products that were made with tritium. And so there's some jewelry items that kind of glow in the dark. And there are some lights that kind of glow in the dark. There are watch faces and dials, compass faces and dials that glow in the dark, trinkets and toys and things that you would give to your children because they're neat to look at and they glow in the dark. And so I was looking at that and I was quite alarmed. I remember the radium dials on watches, and a lot of our United States watchmakers had watch faces that had these little dots of radioactive materials that would glow in the dark, so you could kind of see the minute and hour hand in the dark, and you could see these dots that would illuminate the hour, so you could kind of read your watch in the dark. And so I then went and I posted this part on the internet on usaprepares.com. It's a tritium information. And it says tritium is a radioactive form of hydrogen. As you said, it's used in research, fusion reactors, and neutron generators. The radioactive properties of tritium are very useful. By mixing tritium with a chemical that emits light in the presence of radiation, a phosphor, a continuous light source is made. This can be applied to a situation where dim light is needed, but where batteries or electricity is not possible or practical. Rifle sights and exit signs are two examples of where this phenomenon is commonly used. The phosphor sights help increase nighttime firing accuracy, and the exit signs can be a lifesaver if there's a loss of power. The radioactive decay product of tritium is a low-energy beta that cannot penetrate the outer layer of human skin. Therefore, the main hazard associated with tritium is internal exposure from inhalation or ingestion, as you said. In addition, due to the relatively long half-life and short biological half-life, an intake of tritium must be in large amounts to pose a significant health risk. Although keeping with the philosophy, internal exposure should be kept as low as practical. Now, as I think about this, John, I think about these items ending up in a landfill. Okay, we just throw them away, put them in the trash. We don't know that they're radioactive. We don't think about it, and then they go in the landfill. And then what happens? The bulldozers and the track loaders go over them with these heavy steel tracks and smash them, and then these particles are released. Just one more thing to be concerned about.
Again, what I talked about is the ingestion is where the problem is.
Right.
And just to reiterate, drinking tritium water is not going to be quite as bad for you. Yes, you're going to be getting radiation, but it's like a 10-day span. Mm-hmm. The problem is when you eat the animals that have ingested this and it hasn't been eliminated from their system, they're run through processing. You get the animal meat, you eat the meat. Now you got the issue that radiation is going to be in your body for 10 years, where it can do much more damage.
And there are plenty of animals at landfills. really. You see birds flying over them, and you see other small animals flying over them. I'm sorry, not flying over them, traveling over them. And John, we don't even know what's in our landfills. Well, actually, we do. In one landfill just outside of St. Louis, we know that it's radioactive and there's a fire right next to it, about 1,000 feet away. Captain John Reagan and I will be back right after the top of the hour news and commercial announcements with Fukushima 105. Second hour today of Fukushima. John, do you have any highlights you'd like to share?
We'll start off with measuring radiation, then getting into the history.
There you go. We'll be right back. Everyone all set, cocked, locked. Hour number 2 of USAPrepares.com. Captain John Reagan's with us. This is Fukushima 105. Captain John Reagan, where do you want to begin this hour?
Well, we need to understand a little bit about how radiation is measured. And it's kind of complicated a little bit because of the metric system, because there's basically 2 terms for every type of measurement. The metric system side, System International, and it's abbreviated SI. So when I talk about an SI unit, that's the metric system part of it. When we measure radiation being given off or emitted, the original conventional unit was the Curie, of course named after the scientist Marie Curie. The SI unit conversion is the becquerel. We've heard that a lot in the reports. And that's basically telling you how many counts are being, how many decays counts are being emitted per second. So when we're talking about these huge numbers, billions of becquerels, that's again one of those large numbers that's hard for us to understand. It also tends to be associated with a volume of water. They talk about either per liter or per cubic meter of water. So we end up having to do some conversions when we're trying to compare different reports. But what is being emitted is different than the radiation dose that is absorbed by a person. And that is counted using the rad, or the metric unit, SI unit, called the gray. And you may even have radiation detectors that measure rads, which is to give you an idea of how much you've been exposed to. But to go beyond that, you also have to define the biological risk of the exposure to radiation. Those are measured in REMS, or the SI unit called the sievert. And sievert's a pretty large number, so a lot of times you'll hear millisievert, which again gets into the math. So the conversion of the units, just to make sure you're talking about the same thing, is enough to drive a person crazy, even if you're a numbers person. I've got that from the CDC. I've got another one from Oak Ridge Laboratory. They've got Oak Ridge has the charts with the prefixes and the conversion rates. I've got another link, IRRR, Institute for Energy and Environmental Research, and they talk about, in addition to measuring, they talk about the alpha, the beta, the gamma, and the neutrons. And then the next one, NEI, is the Nuclear Energy Institute. I just gave you the different resources because they explain it in a little different way, and sometimes Just having the different perspective helps. And I took one that was not a more official type source from livescience.com. And that's tends to be written more for people that follow science that aren't really scientists. But the other thing I found out looking at these numbers, the biological risk part, the REM or the sievert, that's basically calculated for your exposure to radiation, not the inhalation and ingestion of radiation. And that's, again, a further consideration because that's what we are getting at the low levels through our air, our water, and our food. And do you have any questions on that? I'm not sure I can answer.
Yeah, John,
I'm not a physicist.
Yeah, I'm looking at the link. How is radiation exposure measured? And the first sentence of this article, livescience.com, says about, and the date was March 15, 2011. It says about 150 people living or working around Japan's damaged nuclear facilities have been monitored for potential radiation exposure, and 23 have been found to be in need of treatment. Now, that's 1 in 6, John. That's a lot. That's a very high percentage.
There was a lot of radiation released just in that initial event.
Mm-hmm. And it says people don't absorb all the radiation they're exposed to. However, most of it passes straight through their bodies. A small amount of the energy carried by radiation gets absorbed by body tissues, and that absorbed amount is measured in units of radiation absorbed, rads. And it affects different people in different ways, but a rule of thumb used by safety crews is that a single rentgen of gamma or X-ray exposure typically produces an absorbed dose of approximately 1 rad. By measuring the radiation level around a person's body, using a Geiger counter, a safety officer can approximate that person's absorbed dose. Now, that's why people wear these radiation badges that collect the amount of exposed radiation and report it, so that someone who can read these badges can say, you've had X amount of exposure, that's too much or not enough, or we can send you back in there to get some more. But my understanding from discussing this with Matt Stein and you and others, is that Fukushima, the radiation levels are so high that we don't have electronics that can sustain that level of radiation without being damaged. Here's what I'm saying. We cannot at this point make a robot that we can shield with enough protection to let the electronics, the servos, the computers on these robots to go in and survey what's going on at these reactors. We can't even make the equipment work because the radiation levels are so high. So it's difficult to fix it because the humans who would be piloting these pieces of equipment, if they actually went in to operate the equipment, let's say a bulldozer or something, that's a death sentence for them. The machines can't take it. We can't take it. Nothing that we know of can survive this. Is that right?
That's basically what it boils down to. We do not have the technology currently existing to even go in and explore for any significant period of time, much less try to remediate it.
Mm-hmm. Okay, do you have any thoughts on what we should do at this point to protect ourselves from the radiation that is all over the planet? I know that Dr. Shealy talks about iodoral and using, iodine supplements. And I even asked him about something that I bought for our animals here at the farm. And you can get this from a veterinary supply house, or even maybe your veterinarian. And it's called triiodine. And Dr. Shuley said that you can take something like a Q-tip and put it on your skin in the area about 1 square inch, or 1 inch in diameter, which is roughly the size of a standard postage stamp. So you could spread that on your skin, and if it's absorbed, within a week, then you need more. If it's not, you're okay. You have enough iodine. That's what I believe he was saying, and I'll ask him again tomorrow about that as a reminder. But that's just one inexpensive way of doing it. But John, do you have any other thoughts as to how we can protect ourselves?
Well, the good news about the iodine is that does help to protect your thyroid, and we are typically deficient in iodine anyway, and you need to cut out your fluoride so that it's not pushing out the iodine to make bad thyroid hormone with. I might also just add a good place to paint the iodine on yourself is the sole of your foot, and that way, it's out of sight, and it's probably not going to mess up any clothes or anything. Either wearing socks or your shoes going to probably have a dark layer where your foot goes into it, or something that's going to be hidden anyway that you don't even care if it ends up with a little bit of iodine on it.
When we come back, I'll tell you where I found some triiodine 7. And it's available in 16-ounce bottles. The price is about $12. I'll tell you a little bit about that when we come back. Class, I just posted triiodine 7, where you can get it. Now, I have no financial interests. I don't even know this company, but I found a source for $10.95. It's called QC Supply. Put a link on the website just so you can see what this product is, and you can find it locally if you'd like. But it's $10.95 for a bottle of 16 ounces. That is what I have. I bought it from a veterinary supply for our animals. And it's a triple source iodine tincture for use as an antiseptic and disinfectant. And it's safe for newborn animals, superficial wounds, cuts, abrasions, and insect bites. 16 ounces, $10.95. Jim in Arkansas, welcome.
Good morning, Vince. I've been listening to your show here a little bit. I've been sort of busy this morning, but of course, I talked to you last night about what I had found out about your not being able to figure out why your belts and your hoses were breaking, and I think I struck on a source for that, which we discussed a little bit. And did you want me to talk about that, or?
Yes, please do. You're on with Captain John Reagan, and you probably know John Reagan from the meetups. And so, Jim, you've been to the meetups, and I really thank you for the call. And what you've done is you've helped us connect some dots. So please share with us the Wigner effect. And let me spell that for the class. Wigner. And I'll post a link right now as Jim is discussing this on the air.
Okay, well, basically, when I was at the meetings, Mr. Finelli was always bringing up how he saw all over the road. And, of course, I did, too, because I was traveling back and forth a lot to Georgia, observing the same things, pieces of rubber off tires, fan belts laying there in the road. And this goes on for miles at a time. So when he mentioned that he was having problems at the farm, I started digging on the Internet and found this man by the name of Wigner. It's actually like he just spelled with a W. But his name is Dr. Eugene Wigner. And originally back in the 40s and 50s, he set up the standards for nuclear power plants. and their longevity. And so what he had come up with was when the radiation gets on certain surfaces, whether it's concrete or steel or aluminum or rubber, the Wigner effect takes place, and it actually goes into the molecules of whatever it's sitting on. And of course, last night, Vince and I were talking about airplanes. And the planes, unfortunately, whenever you take a plane ride, you're being exposed to very, very high levels of radiation because it's up there floating around. In fact, something that I didn't mention last night, Vince, was that I had done some research also that I found out when we saw years ago when we were kids, we saw these bomb blasts, nuclear blasts out in Las Vegas or Vegas area in the desert. And we saw these big mushrooms, and then we saw in the background all these thousands of troops standing there watching this. Well, this was just another test being done of the guinea pig to see what their reactions were. And unfortunately, I found out that the particles, the cesium, the strontium, all these different terrible things, are still in the troposphere floating around. In fact, 85% of those are still floating up there. And of course, this is where all the storms originate out of the troposphere and then drop these particles down, like sort of like a salt shaker. And as you travel in an airplane, you get exposed to these. I could sort of give you a picture of like a bag of poisons floating around. Well, some of these bags contain some of the real bad stuff, actually hot particles, which you don't want to breathe. And then there's other bags where it's not so harmful. And this is what I found traveling across the United States. With my Geiger counter, I have a what I feel is one of the best. It's a Maser. And it registers highs and lows and that kind of thing. And, during rainstorms, I was in Billings, Montana here a few months back, and I was registering 72 millirem consistently in that area. And I hear the music.
Jim, you do. And can you please hold through the bottom of the hour break? And Captain John Reagan, Jim in Arkansas, and I will be right back. This is USA Prepares, and this is Fukushima 105. Class, we're talking about Fukushima. This is Fukushima 105 in the series. And I thought at first there would be, a 1 day special, then a 2 day special, and then we're up to five 1 hour broadcasts. And I don't think we're going to be done with 5 hours. And so this will continue, and we'll keep you posted as more and more Fukushima broadcasts unfold. Jim in Arkansas has joined John Reagan and me. And Jim, you were talking about the Wigner effect, and also that you were traveling with a Geiger counter. Please continue.
Yeah, and of course, wherever I go, I take readings when it's raining and when it's not. And of course, it is always heavier, higher rating, more millirem when it's raining. There's no doubt about that. So it is coming down with the weather. Also, I want to stay on point here with this Wigner effect. What happens is the radiation actually goes into the particles or the cells, we'll call them, of the material. And you can picture these as little balls that are all hooked together or bumped together. And then what happens is the radiation kills like 10 of these balls. Well, pretty soon, after a period of time, you've got like a honeycomb effect inside the aluminum or plastic or whatever, and you really can't see it, like rust or something on the outside. There's no visual effect. But when you find out when it happens, you have what they call incidents in airplanes where the skin starts peeling off the aircraft, or a turbine in one of the GE engines explodes on takeoff. Just last week, there was a plane, I forget what it was, 757, came in for a landing and the nose gear collapsed. Well, it's probably from the hydraulic hoses, from the Wigner effect. And so all these incidents are happening, and if you start looking them up, they're not really what they call, major crashes or anything. They're incidents. Well, these incidents are by the thousands, and it's all happened since Fukushima. So we had the radiation in the air. It was floating around, but this Fukushima has really put the icing on the cake. And of course, now what I'm worried about is this one in Russia, Leningrad here. Now they sent everybody home, and you can't pull up anything on. There's no information, so that makes me a little leery. We don't really need another incident. And of course, Vince, you're right up there with your 240 acres sitting right near that St. Louis dump, which if something happens up there, I don't know what we're going to do, but it's really a sad situation we're in. And I think the key is to keep our immune system high. Like you said, take the iodine, and the diatomaceous earth. There's several other products that are out, and just try to stay healthy. And of course, stay out of the rain. Your hair absorbs cesium and all that stuff just like a sponge. So I always warn the women, especially because they usually have a big head of hair that'll really absorb a lot. So, the days of walking in the rain is over. And the other thing I was going to mention, Vince, that I've looked up is HEPA filters. I don't know whether you've read anything about that. They're good for your house. They're very expensive. But again, the same kind of thing. If you're taking filters in and out of your unit, you may want to use some goggles and maybe a mask. And I know you work out a lot. I wanted to talk to you last night and forgot. I've been doing some research on some masks that are affordable, and you really should be, with the hours you spend outside, because you're going to be picking up hot particles. And of course, you don't need that. And nobody does. And the other thing I was thinking about that came to mind is here we see these bikers out flying around on their bikes with no helmet, nothing on, and they're breathing that air. They're just running through those plumes, and they haven't got a clue of how dangerous it is. And so, just the things that we take for granted, we have to really be aware anymore. And these particles that are coming down, unfortunately, like on your land up there, you've got all that beautiful cattle and everything, and they're just going around eating the grass and stuff like that. So, it's a shame, but we're all trying to eat organic and everything. And I guess what I'm trying to say is we're in a mess here where we really need to band together and try to figure this out. We need people like Dr. Miller, your other doctor there in Missouri, anyone we can get to get information to figure out how to best protect our families and preserve our life a little bit, because we're in deep doo-doo. So.
Jim, if you could see me when I go out on the tractor, I wear like a jumpsuit, something that a mechanic would wear in the 1960s. Zip up on each leg up to my knees so I can get my boots through the jumpsuit. I put that on. I've got a summer weight one and a winter weight one. I wear goggles, safety glasses. I wear a respirator. I wear a hat. When the neighbors see me, they must think I'm an absolute nut. When I'm going down the road on the tractor, I wear a respirator, goggles, jumpsuit. And it probably doesn't look normal to most of these farmers who are, just out there with their ball cap on and their overalls, their bib type overalls.
Well, you're just ahead of the curve. Unfortunately, what they don't know is they'll probably be coming to their funeral, So,
it's really, really sad. And it's hard not to be angry. It's hard not to be angry because the people whom we've entrusted to protect us from these things are generating these devices. They're building these devices. They're testing these devices on we, the villagers, and it's an outrage without our permission. I'm not signing up for this. I'm not agreeing to this. I certainly don't want my cows to be infected and irradiated and chemically poisoned. I certainly don't want that, but there's no escape. There's no escape I can think of. Even in the studio, which is inside a stone house, which is really weather stripped. I mean, it doesn't, our house doesn't leak very much in terms of air. And the civil defense survey meter, the dosimeter that I have, is pegged off the scale. I'm going to reset it and see how fast it goes off the scale again. That's inside, windows closed. How does it happen? It's all around us, as you say.
It comes in on everything. Even if you have a pet that comes near in the house, and your shoes, the old Japanese custom of taking the shoes off. Boy, that's the best thing, because you're tracking that stuff right in the house.
Yeah, and another thing, as a we can complain about this, but let's have a solution. And here's something that I've done here at the house, and I'll share this with our broadcast classroom. When we were building this house, I decided that I picked up some surplus materials to build a central vacuum system. So for less than $100, I got most of the plumbing, the fittings, everything I needed to build a central vacuum system for our house. And I put it in, I roughed it in. And then, I found out that, central vacuum system can cost $3,000, $4,000, $5,000, $6,000, $7,000, $8,000. And that's crazy. But what you can do is you can hook that thing up to a shop vac. And you can have that shop vac air the dust outside. Like let's say you have the pipes end up in your garage, and you open the garage door and you have a flexible vacuum hose and hook the shop vac up outside the garage door. Now you're venting all that dust that you pick up outside, because the last thing you want to do is redistribute that dust with a standard vacuum cleaner, right? And that's what they do.
Yep.
And then I found on Craigslist, there was a woman about 3 or 4 or 5 hours away that had just decided she put in the central vac and she didn't want it. And so she sold us the vacuum. It was like almost brand new. And so I hooked that up and I vented that outside. So now what we do is we have this central vac, and the whole thing probably ended up costing about $400, which is the price of maybe less than the cost of a vacuum that you might buy at Sears, one that you drag around with the short hose, right? So,
excellent move. Yep.
Well, and if you saw the amount of dust that goes out through the bag of a canister vacuum cleaner or an upright vacuum cleaner, it's unbelievable. It's a dust relocation system for the small pieces. And those are the ones we're concerned about, the radioactive ones and these other chemicals that are airborne. So I think that we might want to try that. One other thing that we can share is the furnace filters. What I do is I spray them with end dust, just a light coat of end dust, which causes an electrostatic charge on the standard furnace filters. I'm talking about the ones that have the fiberglass element, if you will. And with a light coating of end dust, it attracts dust like crazy. Then what I do is I find when I clean them, I put a respirator and goggles and all that stuff on the jumpsuit, and I very carefully take them outside so I don't drop any dust inside the house. I take them outside. First, I determine which way the wind's blowing, and I blow them out with compressed air, and I look like I'm ready for a moon landing. So in terms of what I'm wearing. And I make sure the animals are nowhere near us, and the wind is blowing away from the house, and it's going to blow away from where we are, and I just blow that out with a compressor. And then I lightly coat them with end dust again, and back in they go. And my logic is this. My logic is that we'll have the freedom from a lot of restriction of the HEPA filter. We'll have the electrostatic charge on the filter because of the end dust. And it seems to work really, really, really well. And that's what I've done here at our home. Yeah. Now, I don't know if it's the best way to go, or it's certainly one way to go. And I have not replaced a furnace filter in 10 years. The throwaway filters, I still have them, and they work great, and they collect dust. Did you have something else you wanted to share, Jim?
No, I think I'm pretty well set for today. I just wanted to touch base with what I had, and I sure enjoyed your show. So keep up the good work, man.
Jim, thank you so much for being with us today. And we appreciate your advice and counsel. And Captain John Reagan's with us. And class, during the break, you didn't hear it. I asked John Reagan about continuing this series. We're up to 105 right now on Fukushima, and where will it be going? And John, where will it be going?
Well, like I say, I've got a number of links on tritium. I have a number of links about the USS Reagan and what happened to its sailors. I've got a number of links about how this radiation makes it to the southern hemisphere, in addition to the history as things went along with the lies we were told. So we have a ways to go. Okay.
So, class, we're going to continue this. The next in the series on Fukushima will be Monday, next Monday. And that'll be 106. John, you mentioned that you're furious about it. You want to share what that means?
Well, the government made a decision not to tell us that this is happening. So whatever we could have done to possibly protect ourselves, they took that option away from us. And like I say, I've been in this for 2 weeks now, and I'm still furious. And it's not a position I like being in. I don't see any answers at this point. The best thing you can do is whatever you can do to give your body good nutrition and support. But so much of what we've learned about protecting ourselves from radiation is in the picture of having a nuclear event, whether it's what we thought of World War, where nukes are sent over, or like Chernobyl, which they were able to shut down and encase, so the event stopped. What we have here is an ongoing event, which makes this so much more difficult. With the iodine, the idea was to saturate your thyroid with iodine before the radioactive got here so it wouldn't uptake it. Well, with the ongoing event, now you're having to compete with the radioactive, so you can't just saturate it with the iodine, but at least you can try and let your body pick, and kind of like a lottery. And if you have more of the good stuff in there versus the radioactive, you can just hope that it picks up the good stuff versus the radioactive. It's more difficult with these other radionuclides we've talked about. Cesium looks like calcium. Looks like potassium. Strontium looks like calcium. Tritium looks like water, so it can literally go anywhere. And if you try to take something to absorb it, then you're going to have a problem of getting your calcium and your potassium and your nutrition. If you take something to try to chelate it, again, you're going to be taking calcium and potassium out of your system. So that's why you want the medical assistance to make sure that you're putting enough good stuff back in to replace what was taken out while trying to get rid of the bad stuff. So it really is a difficult situation, and we'll continue to discuss it.
John, it's really difficult to have a smile on our face when we're talking about this. It really is. And class, tomorrow, Dr. Norman Shealy is scheduled to be with us. And I'll ask him about what we can do and what his thoughts are, because this is such an overwhelming threat to our lives and our animals' lives and our food supply and the air we breathe and the water we drink. It's just all around us. Captain John Reagan, thank you so much for all your effort and the hard work on this subject. Class, above all, honesty and integrity.